Here's a rather standard type of example for algebra. I have 1 over x minus 1 plus 1 over x plus 2. And all that is divided by 1 over x minus 1 minus 1 over x plus 2. So it's almost identical, top and bottom, except they differ by that sign. One sign, not two signs. So don't know what's going to happen here. But it's a complex fraction because we have 4 levels. 4 different levels here, more than 2. And one approach I can take is to combine these fractions together by addition. Okay, we just learned that. And that would be okay. If I combine those together, then you would have a single fraction divided by a single fraction, because if I combine these together, my common denominator, I'll have one denominator. If I combine these, I'll have one denominator. Then we can invert and multiply. I assure you that's a long way of doing it. So I'm not too inclined to take up camera time and show you the long way on this. But it does work. It does work. Here's what does not work. You cannot invert these. Okay? You can't take this mess and divide it by x minus 1 minus x plus 2. So never invert a sum of fractions or a difference of fractions and then multiply. It's a disaster. All right, it's utter disaster. So never ever invert an addition of fractions before you multiply. Doesn't work. All right, so let's do this the right way. And my common denominator would be the product of these two smaller denominators. All we have in as far as small denominators are x minus 1 and x plus 2. So I'm going to multiply up here by x minus 1, x plus 2. Down here I'm going to multiply by the same thing, of course. And we always have to multiply by the same thing, otherwise it changes the value and screws up the problem. Now what's going to happen? When I multiply by these two factors, each of these are going to cancel. Same down here, they're going to cancel. So, the brilliance of this method, I wish I could take credit for it, but I can't. Brilliance of this method is that it changes the complex fraction into a simple fraction very rapidly, very quickly. And that's why it works so well. Now, I want you to try to follow me here. When I multiply this product times this fraction, x minus 1 is going to cancel. So I'm going to be left with 1 times x plus 2. And then here I have plus. When I multiply these times this fraction, x plus 2 is going to cancel, leaving x minus 1. How about that? Down below, when I multiply this product times this fraction, x minus 1 cancels, leaving 1 times x plus 2. And likewise, multiplying this times this fraction, x plus 2 cancels, leaving minus x minus 1. Now with the minus, I put parentheses up because I'm subtracting x minus 1, the entire binomial there. So careful there. This would be an easy place to screw up. All right, so let's simplify our fraction. We've got combine up here. We've got 2x and then plus 1. So 2x plus 1. Down below, I have, let's see, x plus 2 minus x plus 1. So notice the minus x and then the two negatives cancel, giving me a plus 1. So there's that distribution. These x's are going to cancel off, leaving a 3. So my final answer is going to be 2x plus 1 divided by 3. And there we go. So that is, I'm quite sure that's the fastest way to work this problem. And it's a really nice method that's been developed for these.